looks like maybe somewhere future we'll get an over ceiling mounted projector in here, but sorry it didn't happen this term. Maybe we'll have it for the final when you don't need it. Okay. All right. Now, before we get going on today, then, let me go over just a few more things. How we're going into the term. Okay, today we're going to finish up chapter 8. We don't have that much further. We have 8.5, which is a little over 2 pages, no, just under 2 pages. 8.6, about the same, and that's it. So we should be finished with this fairly quickly today. Okay? Then we're going to do the lab on chapter 8. Okay? It's all a paper lab. You'll have your books. You can work together as a group, and come up with the lab. Okay? Then, for those who choose to, and I've already had at least one person indicate he's going to, you can take chapter 8 test if you want to. If you want to digest what we go over today and come back anytime later today up until I leave at 8, or, and here's Michael. Okay, now Michael, I've already passed out, I wish, all the quizzes, labs, and tests, but I'll get you at the end. I'm not going to go through them all now. Your paper is due, and if there's anything else you need to turn in, get it to me.
I was late because I was trying to get the print off, but it wouldn't when I have it on this hard drive.
Okay. Okay. All right.
You want to take it, or you want me to go get it?
No, if you can either email it to me or print it, but
Okay.
Anytime today.
Okay.
All right. After today, you lose points. Okay. So we'll finish the chapter. We'll do chapter 8. We'll do the lab on chapter 8. Y'all, like I said, you can do it as a group, individuals, pairs, however you want to do those. It's all from the book, paper copy. One sheet. Pretty easy. Okay? And then, if you want to, you can take the chapter 8 test, or you can digest what we've done, get your formula equation sheet together, and come and take it later today. I'll be here till 8 tonight. I'll be here all day tomorrow from basically 7:45 until around 4:45 or 5-ish, okay? And then Thursday, I'm here all day, 7:45 to 8 o'clock at night. All day, you can take it then. That's technically when it's scheduled, okay? Same thing about the final exam. I've got it ready. If you want to take it today, you can. You can take it tomorrow. Later today, you can take it tomorrow, or you can take it on Thursday. Everything has to be completed by end of business on Thursday, which is 8 o'clock Thursday night, because I'm driving to New Orleans on Friday. So no way to get me anything after Thursday night. So get me that kind of stuff done. By the way, there's pizza there if you want pizza. Okay. All right. Any questions before we get started? And also, the other thing, have you done the student course evaluations? Yes? Okay. If you haven't, please do those. Please do those. Okay? And let's see, anything else? Oh, let me just, a little bit of housekeeping type thing. If you have noticed, I don't know, I haven't checked it, but usually at the end of a term, they shut down Student Suite to the students, okay? The reason for that, there's only, this is ridiculous, only like 16 ports. And if all the students are checking their grades constantly, we can't get into the system to put your grades in. That happened the first time they went to this crazy system. And after that, they usually shut students out. But I will first put things on Blackboard. You're not shut down from Blackboard. I don't have the stuff there yet because I'm still grading like crazy. But I will, as soon as I finish the grading, I'll be putting everything on Blackboard. And I'll put your grades on Blackboard, and then I'll put them on Student Suite. Then sometime after Monday noon, they'll open Student Suite up again. So you'll be able to see it after a while. But please check and make sure the same grades in Blackboard that is in Student Suite. I try to do that, but maybe not everybody does. So it's a good idea to check on that. All right. Any questions? later you're going to start. Okay? Okay. When are you going to do the lab?
That's going to be my one mid.
Okay. And you'll probably need to go next door or somewhere because I'll be talking about this as.
Is this both of them?
No, that's just the first. And when you finish the first, I'll give you the second. Okay. Okay. So, any other questions? All right, where we left off last time, depending on which edition of the book you have, is around page 219, 8.5, the periodic table. Now, this is a pretty incredible document, the periodic table. I don't know if I think they mention him later, much later. So I'll wait and hold off on him. But it was developed over time, but one Russian scientist really put together the closest thing we've got to it now. It was filled in a little bit more by others, but pretty incredible. They started noticing that certain chemical properties repeat themselves as they go through these various chemicals. And we understand this, we explain this by the fact that these that are so similar have similar electron configurations. Now, I've already talked to you some about that, but we'll talk about it a little bit more. The electrons in the outer orbits are the ones that determine the chemical properties. Those that are buried on the inside, they don't get exchanged, they don't get shared, they don't get anything. It's only those outer electrons. Whatever electrons are in the very outermost shells, they're the ones that determine the chemical properties. And this whole concept is summarized in the periodic table. Now, you've got it in your text. What page is it in yours? Mine is on 220. And if you have the big book, it's also the back inside cover. Okay? Now, I see some others are open to it now. Let me kind of go over that here. We have what we call rows and columns. If you hold the periodic table up, landscape mode like this, the rows are the horizontal sheets. First row is only hydrogen on the left, helium on the right. Okay? That's the first row. Why? Because the 1, n equal 1, that's the primary principal quantum number, only has one subshell, the S subshell. S subshell only has one pair of electrons. Hydrogen gets the first, helium gets 2. Okay? They filled the shell, helium doesn't react with anything. It's got a full shell, doesn't react with anything. Okay? Then you go to the second row. Lithium has 1 in the outer shell, that's why it's underneath hydrogen. That's what hydrogen has. Only has one in the outer shell. Beryllium has 2 in the 2s shell, and you jump across the boron to start filling the 2p shell. And it has one, by the way, the rows then are the n numbers. N equal 1, n equal 2, 3, 4, up to 7. Okay? Those are the rows, the n numbers. The columns are the families or groups. 1a, which is underneath hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, which no one ever uses or knows about. Those are called the alkali metals. Okay? 2a, beryllium, magnesium, calcium, strontium, barium, and radium, they are 2a. They have 2 electrons in their outer shell, the filled s electron subshell. Jumping way over there to column 7, these are the halogens. Fluorine, chlorine, bromine, iodine, actinium, you never use that, and then whatever is underneath that. Those are your halogens. What's special about those, They have 7 electrons in their outer shell. Guess how many do they want? 8. So therefore, they're really reactive. They are hungry to grab an electron and combine with somebody. Just like the alkali metals are, like I said before, you never see pure sodium. You don't. It's always reacting with something. You don't see pure calcium hardly, or any of those, because they're reacting with something. You never see pure halogens except that if they're in the elemental form, like fluorine gas, chlorine gas, iodine, you can have them, but they're in their elemental form. Now, the last one they mentioned here, the noble gases. That's column 8, or 8A, okay? Those are the ones like helium, neon, argon, krypton, xenon. There is really a krypton, by the way. Radon, okay? Those are filled shells. Their outer shell has full 8 electrons. They don't react with anything, nothing, okay? So there's for your A's, 1A, 2A, then jump over the boron, 3A, 4A, 5A, 6A, 7A, and 8A. Those are filling the 1A and 2A are filling the S electron subshell, and then the 3A's through 8A's are filling the P's, okay? With the noble gases 8A having completely filled outer shell. Okay. These A group families, the ones I just mentioned, are the main group in representative or representative elements. The B group, and they begin with scandium. You see 3B, 4B, 5B, 6B, 7B, 8B, 9B, 10. I can't believe they said that. 9B, then 1B and 2B, okay, or not to be, okay. Those are your generally your transition elements, also called the metals, okay. Now, what's special about those? You're now filling the D shell, okay. The D electrons tend not to be fixed to one particular atom. They move around as clouds and can easily move from one to another to another. This is what makes metals such good conductors, both of heat and of electricity. Those are your B group, the transition elements, or the metals. Okay? Now, it's sort of bizarre that they start with 3B and end with 1 and 2B, but that's just the way they do it. Okay? All right. Helpful to look at the table as you're reading the text or doing this. Okay. Now, here is the periodic table. I should have done that rather than hold it. Again, your rows are N equal 1, only has 2 electrons in it. N equal 2, 2s, 2 p's. N equal 3, 3s, 3 p's. N equal 4, 2s, but then you go back and catch up on the 3 d's. Remember that chart we did the other day, okay, last Thursday. These are your metals, the D electrons. Then you go back and do the 4 P's, starting with gallium and going through krypton, okay? Then the 5 S's, these 2, and then the 4 D's, yttrium through whatever that is, cadmium, I think it is. Then you start filling the 5 P's, okay? And these 6 fill as 5 P's. Then you come down and do the 6 S's, the 5 D's, the 6 P's, and then you come down and start on the 7 S's, these 2, okay? But then, okay, I'm sorry, skip one. The 6 S's, 1, 2, 3, 4, 5, 6, 6 S's, before you go to any D's, you start filling the F's. Okay, remember there's 2 S's, 6 P's, 10 D's, and 14 F's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These fit in after lanthanum. Actually, lanthanum is the first one, and lubidium or whatever that is then the P, okay? I mean the D. But they just set it up this way. And you go through that way. So this is, what was this, 6S. But before you get into the P's or your D's, you do your 4 F's, okay? And do those 14. Then you come back and do the 5 B's, and then you do your 6 P's, okay? Then you go to 7S, okay, 2 here, and then you go to 5F, and these are them down here, and then you go up and start filling in the rest of them, which are your 6 P's, D's, okay, getting the letters straight. And we don't have all these that we know of yet. Some of them they sort of think they've identified, but here's something about this. All these that have parentheses around them, notice here, most of these, the atomic mass is a decimal number. Some of them are whole numbers with parentheses around them. Why is that? These are radioactive. These heavier ones are radioactive, and they don't hang around very long. Okay? They have identified them, but they're only briefly there, and then they've disappeared. They decay really, really rapidly. Now, your lanthanide series here, those are all still good. Okay? This is 0.0. Those are still good. But then once you get into your just about here, that's where your radioactive ones start. And most of the rest of them are. Thorium is not, but and uranium is not, but the rest of them are so radioactive they don't hang around very long. Okay? Very short half-lives. All right. Now, before we pass on, there is on page 219 also table 8.4. The electron structures of the alkali metals. Okay? Remember the alkali metals, this 1A column. Okay? Lithium, sodium, potassium, rubidium, cesium, and francium. Okay? Okay? And basically, here's how they do these sometimes. Rather than writing all of them out, they take the last noble gas, like neon, and sodium, well, okay, back up one more, helium, and then add 1 s electron to it, okay? Neon, add 1 and you got sodium. Argon, add 1 and you got potassium, and on down. So that's why they abbreviate them that way, and they only list that first one. But the number of electrons in the main energy level in the first 1s, 2 electrons, all these. 2 p's, okay, this is total. There's 6 that are p, but then you still have the 2 left over from your 2s, so that's why they're listed as 8. Okay, and then potassium picks up 1 in the third, and then you can have up to 18. It has 8 in its row, but then you add the 10 d electrons, and you have 18. 18 here. They don't go any further, but the next level, you get to 32. That's the 18 and 14. That's your 32. And the 5th level only goes to the 18 because you don't reach past here any longer. You don't have any more below it. Okay, so that's just another way of expressing that you don't have to list all of them, just list the last noble gas before you get to that. All right. The noble gas family, those basically, for helium is just what it is, 2 in the shell, okay? Neon is helium plus 2s and 2p, so that's 8 more. Argon is neon plus 8 more. Krypton is argon plus 18 more. The 10 in here plus your 8 over here, okay? So sort of strange the way they list that. And then xenon is krypton plus 2 and 8 and 6 or 8 plus 18. It's sort of bizarre how they're listing these, okay? But then you have radon is xenon plus these plus your lanthanide series, and that's where the 32 comes from. So this is just sort of a shorthand so you don't have to list them all. All right, Tiffany's here. Okay, there's pizza if you want it, and let me find you. There you are. Earlier I passed out labs and tests. So if you catch me, after we finish this, when we have some spare time, I'll go through it. In fact, while y'all are working on your labs, I'll be passing on the others. Okay. And there's plenty of pizza, so eat up. All right. Now, before we go any further into metals, nonmetals, and semiconductors, there's your paper. Great, thank you. All right. Now, please, folks, don't put papers on stacks that you're not sure what's in those stacks. That's where things could get misplaced. Give them to me, and I'll put them where they need to be. Okay. There's a concepts applied periodic practice. It says identify the period and family of the element silicon. Write your answer. That's the kind of stuff y'all are going to be doing in lab. Okay? So that periodic practice, you'll be doing some of that in the lab. All right, moving on to 8.6, which is the last section here, and there's a bit to do in it. Metals, nonmetals, and semiconductors. Okay? The noble gases have filled shells. They are inert. They're going to say that several different ways. They don't react with anything. That's why something heavy like radon, anything with a molecular weight of radon, or much less than radon, is usually a solid. But because it's a noble gas, it doesn't even connect with each other. It remains a gas. Very heavy, dense gas, but it's still a gas. So all those noble gases, they are gases, even though all the things around them are solids. Okay? There aren't that many things that massive that aren't solid, but they are. Now, if you have materials with only 1, 2, or 3 outer electrons, I mostly think in terms of 1s and 2s, some 3s. They really love to lose those electrons, so they'll have a filled outer shell. They just lose those few electrons in their outer shell. They become positive ions because they've lost electrons. Many of the metals are like that, okay? But remember, the metals have whole clouds of electrons that move around, and that's how they do it. For those who have 5 to 7 outer electrons, of course, 8 outer electrons, noble gases, they don't react with anything. 5 to 7 outer electrons, I usually think mostly in terms of 6 and 7, though some 5s, they tend to gain electrons because then they're going to fill up a shell. If you have 7 already, all you need is 1. If you have 6 already, all you need is 2. 5, you need 3. That's sort of hard to get, but you can get them, okay? These tend to be nonmetals, okay? Now, especially those that 3, 4, and 5, they tend to share electrons more than ripping them off or losing, okay? these are your non-metals, usually 5, 6, and 7. Those would be 5A, 5B, 5A, 6A, and 7A. Non-metals, and they are very reactive, especially the 6 and 7s. Now, in between these, we have our semiconductors. Now let's go back to our periodic table, and here's where they stand. Metals on this side, in the middle, the transition metals, the non-metals over here, okay, these are your semiconductors in here, somewhere in here. What do we call the valley in California where they have all this? Silicon Valley. There it is. It's a semiconductor, okay? And so that's where the one in the book actually colors them. The blues are your metals. The grays or tans or whatever you want to call that are your non-metals, and the greens are your semiconductors. Intermediate between metals and non-metals. Okay? So the periodic table tells you all sorts of stuff. Amazing amount of stuff. Okay? And here we have it again. Here they did columns 1A and 2A. Hydrogen through francium, beryllium through radium. Okay? Then we have over here, now this is also a new notation. Okay? Pay attention to it. When you have a single dot, what that means, that's your outer shell electron. Okay? Excuse me. Outer shell electron. Notice everything in 1A only has one. Okay? Everything in 2A has two outer shell electrons. These are easy for them to lose, and when they lose them, they go back to the electron configuration of your noble gases. Then jump over to 3A, skip all those metals in the middle, boron, carbon, nitrogen. Okay, these have 3 electrons in the outer shell, 4 electrons in the outer shell, 5, 6, 7. Finally, when you have 8 in the outer shell, they're completely filled. Not wanting to react with anything, and all of these are gases. Even these heavy things down here are gases. Nothing else is a gas here. Chlorine's a gas, but nothing else down here are gases. These are heavy, heavy molecules, but they don't react with anything, so they're still gases. Okay. These tend to lose electrons. These tend to gain electrons. These in the middle can't make up their mind. These mostly share electrons. I like to count all 3 of these as sharing electrons, especially these in the middle, 4A. Okay? And that's the electron dot configuration. When you see it, that's what it stands for. Notice they don't do the D's and the F's, okay? They only do the S's and the P's in the outer shell. Here it is. Here's our periodic table with the metals here, the non-metals there, and the semiconductors here. And of course, what they left off, the noble gases don't react with anything. The metals tend to share, lose electrons or let them move freely. These tend to gain electrons, and these in the middle, they are intermediate between the two, your semiconductors. All right, any questions? That's all she wrote for the slides. Let's go over just a few more issues here. Let me go back to the periodic table. Not even that one. This periodic table. It's in your text, like I said before. It's just another name. The rare earths. That are these. It actually starts with lanthanum and goes across to ytterbium or whatever that is. This one actually is the one that belongs right there. Thorium across. These are all radioactive. these are called the rare earths, okay? They're rare, they have rather strange properties, and they've been people have found some really unusual uses for them. So they are being rare, they can be fairly valuable, okay? So I'll let you read that one. It's really worth a read. And then on page 223, the guy I was starting to mention before, Dmitry Ivanovich Mendeleev, okay? He is one largely responsible for coming up with the periodic table. Incredible character that he was able to put together way back when he did this. A brilliant Russian chemist. Well worth a read. However, if you're choosing to do your paper topic on him, this can't be your source. This can give you ideas. You have to have your source on the outside. And by the way, the papers are due today, not to lose any points. Get them to me after today, you'll start losing points. But get them to me. You don't want a zero. It'd be better to lose a few points than to get a zero. Then there's also the metals and the charge. That's something we've been talking about, and that's well worth a read too. And then the semiconductors, the one that they mention here, the gold kind of color there. There's a blurb at the top of 224 for that. There's also another concept applied about the outer orbitals. Again, well worth a read. Okay? They have a few more figures that didn't show up on the slide. I'll let you read that and see what's happening. This illustrates how if you have one electron in the outer shell, it's real easy to lose that one. Then your next, if you lose that electron, you don't have an outer shell anymore. Then the shell below that is completely filled. Okay? Now it's very stable, except it's an ion, not an atom. Fluorine, on the other hand, has 7 in the outer shell. It loves to pick up an electron. And if it does, then it has 8 in its outer shell, and it's happy camper then. But it's charged. It's a -1 charge. Lithium is a +1 charge. Lithium and fluoride come together, held together electrostatically, because one's positive, one's negative. That makes a very strong bond. Okay. Your summary there, I think, is one of the longest summaries we've had so far. After you've read the chapter, go through the summary. Equations, about average, maybe a little on the light side, only 5. Several of their previous chapters had 10, 11, something like that. Key terms, quite a few of those too. They start on page 225, they continue on 226. Applying the concepts, the multiple choice questions, 49. That's probably on the upper side of average, okay? So I would definitely do those. Then questions for thought, 12's about normal, 6 for further analysis. That may be a few more than normal, but pretty close. Parallel exercises, quite a few of those, 229 and 230, okay? 230 has a lot of multiple things in it, so you might want to take a look. If you've got the big books, the answers for Group A are in the back. If you have the little thin book, they did not print the answers. I wish they had. Okay? Any questions? Chapter 8. Yes?
Is that why in the blast furnace at the steel mill, they said there's one gas that attracts the oxygen. Is why it reacts, I forget how to put it, it reacts, takes the oxygen from the air. Carbon dioxide.
Yeah.
Is that why it
Yeah, okay.
feeds them?
Yeah, very good thing. Now, if you look at it, carbon's in that 4A column, okay? Meaning it has 4 electrons in the outer shell. It doesn't gain them or lose them, it shares them. And oxygen has 6 in its outer shell. It wants 2 more. So one carbon shares 2 of its electrons with oxygen, but these are called covalent bonds. That's the next chapter. We're not going to get into that, sorry. And that's for 2 of CO2, carbon dioxide. Now, is that what you were asking? Or?
Yeah, I was just kinda curious why it attracts, why it wants those.
That's why, because of the electron configuration. H2O, oxygen has 6 in its outer shell, hydrogen has 1. They combine together, that gives 2 for hydrogen. It shares 1 with an oxygen. The other does, so they share, so everybody's fat, dumb, and happy. Okay? And that's exactly what happens. NH3, ammonia. Okay? Just about everything has sodium chloride. It loses 1, that gains 1, they're happy campers. It has outer shell like neon, and with 1 more for chlorine, it has outer shell like argon. They're happy, but they're held together electrostatically because now they're ions, and they're really held well. Okay. So yeah, just about everything chemically can be explained by position on the periodic table. It is amazing. And Mendeleev saw this way before hardly anyone else saw it. A few people have sort of had glimpses of it, but Mendeleev really put it together. Did that answer what you were saying?
Yeah, just how that works.
Okay.
I still don't really understand totally. I get the idea.
Yeah. And if we had time and you got the book, go on and read chapter 9. It'll explain it a little bit better. Okay. But we just don't have time. All right. Any other questions? Y'all ready to start your lab? Okay. And again, it's just a paper lab with no. Okay. I've got to find it now. Yeah. I'm sorry. You have the last test first. Okay. Okay. Even though. Oh yeah, absolutely. And we're gonna have the lab in here, since it's just a paper lab. We'll be in here. You understand, Zach? We're gonna be in here for lab. Yeah. What?
Because I'm fine with all my other grades, all my other tests.
Okay. Well, you lose the opportunity to drop one of those. I don't know what's happened to you, but you. How about the lab?
Then I'll just use these last 2 as my.
Okay. All right. I don't know where. Oh, I see. This is. Okay. Okay. You'll probably need to go in another room to do this. All right. Now, these are descriptors, that kind of stuff. These are words or phrases. Okay. Yeah, put the letter here that corresponds to that number. Find the letter here and put it there. Okay. And if you could, maybe go down to 251. I think Nick's next door, but he's doing a different test. So if you could go to a different room.
All right.
Yeah. All right. Oh, there he is. Speaking of whom. Okay. Are you going to do the lab?
No. This will be my one.
Okay, yeah. Okay, so you're going to start on the final? Okay. Okay. Yes, sir. Okay, thank you. Okay. Oh, good. What's that? Oh, it's what? 2 hours, wow. Yeah, those writing things can drag on, can't they? Okay. Okay, I'm going to. Okay. Y'all want to go on and get your lab so you can get started if you want to? Manuel, did you want yours now or wait till everybody else? Huh? And I'll go over it, so don't make any guesses. We'll go over that. You want yours now or wait till they come back?
I'll wait till they come back.
Okay. All right. we will do that. I may run down and help me a little potty break too, so. I'll be right back. At least it smells good in here. Well, hello. We just finished the chapter, so you'll have to, if you want to, it's not up there yet, but when it does, you'll be able to
I stopped and got some
cookies.
Cookies
That's
for
so nice of you.
and then about it.
Okay.
So you finished up 8?
We finished 8,
Okay.
and I'll be returning the other stuff to you, so if you want to
Okay.
just sit and relax or whatever.
Are we gonna stay in here
We're-
for lab? Or
Yeah, we're going to be in here for that. Okay. I'm going to be distributing some of these other labs and stuff.
Nicholas. The one that never come. That's the one with dark hair.
My memory's right. This is Tiffany. This is Emmanuel. Siegfried's not shown yet. My word, I don't think he hardly missed a day all term. Michael, where did he wind up sitting? Huh? Is this it right here? Yeah. Okay. That is Lakeisha. Where did she set up shop. Right over there, I think, wasn't it? Which is Lakeisha's.
Did you get my email? I sent it to you when we were sitting there. I don't know if you
No,
got
I
it.
haven't seen emails that I've been.
Okay.
Yeah,
That's fine.
okay. Lakeisha, is she here or there?
No, I can guess what I got.
Here? Okay. Anika hasn't shown up yet. Who is this? Secret. Okay.
And I have this lab for you to train.
Okay. Okay. I didn't know where you were.
Okay.
Okay, yeah.
Okay, this is my stuff here. Okay.
I'll put it wherever you're going. Why?
Yes. Yes, sir. Wash my hands. Yes, sir.
Boy.
Oh, let me see. Let me see. It's empty. Oh, yeah. Oh, wow. I'm too late. Cat don't get it.
Mandel. Siegfried's not here yet. Michael. Patrick. And Lakeisha.
Thank you.
Right. Anika's not here yet. Bet.
Siegfried's like getting everybody's number. They're like, he's like, let me get everybody's number. I'm like, okay, I gotta go. There's a squirrel fucking.
He outside.
Yeah. Who wanted that number? Siegfried, the guy that calls Lacey with him.
Big Brown?
Yeah. He was like, look at everybody's number. I'm like, I better go.
Why do you want everybody's number?
Oh no, we didn't get mine.
We can call him McBride, y'all crazy.
Generally not. How you doing? I just want to see how you doing.
Yeah.
Start up conversations. You talk in the morning. Big five and then.
What do you want?
Lakeisha brought the cookies.
Rob was there. Look great.
Siegfried's not here. Michael.
Y'all got a lamb already?
Patrick. You want yours?
Is that it right there?
I'll get it.
Okay. Thank you.
I'll find it in a minute. So don't-
Okay, yes, sir. I got a bad sign, my sinus is killing me. Got me here, man.
All right. I'll be right back.
Yeah, I know, our motor shows up, messes everything up.
I've got some other things to get to later. Patrick back here.
Literally what he said.
Dr. Fowler, is this Nick right here?
Huh?
Is this Nick's?
Maybe, yeah. You can move it up. He's next door taking it down. I'll be right back.
Thank you for the cookies. You did good.
You're welcome.
Oh, who brought cookies? Parker. Nah, nah. Oh,
Hey, did you you asked
Don't
about
listen to her.
oh,
I know, right?
for the
Tell-
first,
tell 'em.
for the first time in all the class, you know, I didn't hear it, I'm trying to get. Did she give you the phone, put the number in, Phil?
Don't nobody want you there, they know.
I got to get the numbers. So we got a box of pieces? We got a box? Okay, Dr. Fowler, thank you.
What's that?
I mean, Dr. Fowler, thank you.
Okay, sir. Yeah, y'all ready for the lab yet? Or y'all still moving?
Are we gonna do live here or no?
Here, we're doing the lab here.
Look, man, look, they got you set up on the screen.
They're trying to.
Look here.
They don't have it done yet.
This here.
I guess it plugs in here and runs
Look
to
at
there.
that. Oh, wow, they got you, oh, man.
I'll be right back.
Oh, man. Cool.
I had a block Heidi's number the other day. Actually, I did. You got no way up. No, I didn't have to. She's so good. That's not the reason. No, correct. She's not good. Yeah, that's the worst part. Yeah, I mean, they're there. Like, she's silent. They just say, put her off the lead. Here's something. It's cutie. I'm not allowed to be Heidi. She thinks me and Heidi have a thing going on. She thinks that I'm flirting with her. You know we don't fucking help. Why do people? Okay, now you say it.
Is this yours here?
That was yours.
Um,
This was yours.
Yeah, I gave it to you, right? If you wanna go to the next door, yeah, there would probably be the best place. There's one guy in there taking the test, you can, not gonna bother him, but, is that your, yeah, that's yours. I'll be here until they finish, and then I'll be in my office at 8.
Yeah, when it was Jonathan, I was like, all right, at least I got a number that's close. They're good.
No, I'm going to pass out, so everybody settles down. I'm just passing Okay. Y'all ready for today's lab?
Almost.
What's that?
Almost.
Okay.
Oh, I didn't have, the lab for today is.
I'll get it. I'm just asking if y'all are ready for it. Okay. If y'all are ready for the lab, I'll pass them out to you. Some of you got yours. You got it, right?
Yes, sir.
Okay. But Siegfried didn't.
No, sir, I'm working on it now, Dr. Powell.
Okay. Here's today's lab.
What's your name and number?
Pass it over. Everybody sure got one, right? Okay. Okay, still got some others. Hey. Okay. All right.
You don't play basketball, do you?
No. White man can't jump.
I can block, but I can jump.
That's the name of the movie, Cat.
I know.
I slap him.
Okay.
I've been waiting.
Okay, I wish everybody were here, but they'll have to pick up. Okay, this is what you fill out for the lab tonight. Okay?
Okay.
1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So 32 possibilities here, but there's multiples on all of them. Be sure you put your name on it. Okay, now put at the top the atoms. Carbon, magnesium, iron, and gold. Okay? And you are to fill in the number of protons from those atoms. And it's a pretty easy thing to do if you paid attention when we were doing it in class. The number of neutrons, just a little more work, but not much. Number of electrons, pretty easy as well. Then you do the electron configuration. And just to refer to it in the book, okay, this will be like you see on page they do one for strontium. Okay, oh, here we go. On page 218, 8.3. Okay? In fact, some of those are there for you, but others are not. You'll have to do those yourself. Okay? Then the period. Okay? We talked about that, which one were the period and which ones were the families. I'll give you hints. Either rows or columns on those two. Okay?
Either rows or columns.
Yeah, you have to figure out which. You have to name them. Okay? And then the metal, non-metal, or semiconductor, you can find that in the text as well. And you'll find that on page 220 and what you read in section 8.6. Okay? And then number of outer orbital electrons. You'll pick that up either from what you read or from the periodic table. Most of them you can pick up from the periodic table. Did everyone get a copy of the lab? Oh, you didn't? Now, if you have any questions, please ask. You can work together. Okay? I should be recording this. Oh, I am recording this. I forgot. That was a lot of dead time on there, folks. Wow. Okay. All that was being recorded. But for those who are not here, that's how you do the lab tonight. Now, I would highly recommend you turn these in tonight so I can grade them and get them back to you on Thursday. Okay? Or hopefully get them to you. Anyone who did not get a lab. Okay? Now, I'm going to pause the recording now. If you have questions, I'll try to remember to turn it back on.